The CCARC 2019 Field Day Lectures, speaking on free digital voice.
Thank you. Good afternoon, everyone. Thank you for coming. I'm going to be talking about FreeDV. These are some of the topics that we'll be covering. What is FreeDV and why do we want to use it? How do you get on the air with FreeDV? Who can I talk to? And also I'd like to talk about a couple of new modes. So the first part of the presentation will be just introduction to FreeDV, and some of you may have seen this before, but then we've got a couple of exciting new modes coming up that I'll be talking about and demonstrating towards the end of the talk. Okay, so why would you want to use FreeDV? Well, what we're doing is arguably one of the leading edges of ham radio. We're doing some of the work we're doing here isn't even been done in the commercial world yet, or it's equal to some of the best stuff that's coming out in the commercial world. We've now got, with one of our modes, low signal to noise ratio performance. It's equivalent to SSB, and in some cases better than SSB. So you can get voice through where you can't get through on SSB. Using FreeDV, you can avoid some of the problems with HF background noise. It's becoming increasingly a problem, especially in urban locations. We've got performance just as good as any commercial system, in some cases better. It's a voice mode designed by hams for hams, unlike having to take something off the back of other commercial services. You're not locked down by commercial companies. You're allowed to get in there, play, experiment, and that's because it's based on open source software. This is a software-based mode, and people are welcome to experiment. No legal barriers to experiment. Some of the other digital voice modes on both VHF and HF are based on proprietary patented codecs, and you are explicitly forbidden by law to experiment by them. That's the license condition you accept by using them. Not so with FreeDV. It's all open source, and you're free to experiment. And it's a pretty low cost of entry. You can start by just downloading an application for your desktop computer. So, how do we get on the air? The easiest way is with the FreeDV GUI application. That's an application that runs on your desktop PC, Mac, Linux or Windows, and it allows any SSB HF radio to be used for digital voice. It just feeds signals into your microphone and they come out the speaker and lets you get on the air with FreeDV. It's been around for about 7 years and has enjoyed some popularity with ham communities around the world. It also supports several digital voice modes. As we develop them, the leading edge tends to come out first of all on the software application. This is what it looks like when it's running. I'll just use this pen, but certain things of the window here is, this is the spectrum that's being received off air. So this is the FreeDV signal in here. And that's just an interfering carrier that's not interfering with us. This is a waterfall display. This was over a HF channel, so the signal was coming and going a bit. The red is the strong signal. This is where we lost it for a little while, and that's that interfering carrier over time, which the signal ignores. You can't hear that. Down this side there's some controls and a mode setting for which FreeDV mode you're using. And over here some diagnostics. That's the signal to noise ratio that we're receiving the signal at. Some indication of whether you've got synchronisation with the other end, and some other statistics such as bit error rate. So that's what you see when you're running FreeDV, the GUI program. The way you hook it up is you take your regular HF SSB radio and you connect it via some sort of sound interface, such as a signal link, or some radios have a USB sound card built into them these days. Unlike other digital modes, you also need a second sound card where you hook up to for you to put sound into the system. So it needs 2 sound cards, and we typically use a USB headset for one of those and your rig interface for the other. So that's the sort of hardware you need to get going. That arrow up there is an error from the conversion from Linux to Windows of the presentation. That part's not going too well yet. Another way to get on the air is with the SM1000 smart mic, a little blue box. It's a little embedded box that combines a bunch of those other boxes I showed you on the previous slide. It includes all the rig interfaces, the computer, a microphone, a speaker, and that connects directly to your radio to get on the air with FreeDV. That was designed about 4 or 5 years ago by myself and a US ham called Rick. He was a retired embedded engineer, and we had a really good time designing this. As I said, this is all coming together from the efforts of volunteer hams around the world, and having a good time doing it, gradually improving and developing year on by year. Now, initially and for the last few years, the SM1000 has only supported FreeDV 1600, one of the original modes, but we've got a bit of news on that that I'll talk about later on in this presentation. That's what it looks like. It's a little blue box, about that big. At the front, you've got a bunch of connections to your radio, such as the microphone and speaker connection. It's got a built-in microphone and speaker, or you can plug in a little analogue headset if you like as well. And that's everything you need to hook up to a radio, useful for portable work, for example. Now, the other way you can use FreeDV is it's basically the whole thing's free software, and we distribute it in an open source library in the C software language, and that can be included in any SDR project. So there's several people who have just taken the software, downloaded it, and then integrate it into their project. One example is this interesting radio. It's from the MCHF project, or the latest one is the UHSDR project. A bunch of very talented German hams putting this together. That's a standalone HF radio, and it's based on the same microcontroller that we used for the SM1000, the little blue box. So what these people approached me, and Danilo has been a very helpful guy. He's a very talented software engineer, and he took the software that I wrote and he made it run about 4 times as fast. He just sat there, and then he sent me the fixes, the corrections. So, really sharing in the ham spirit of improving and sharing information. And he's got it running on this SDR radio with his team of hams over in Germany. And so he just includes my software, and away you go. He's got FreeDV in his radio. Okay, to find it on the air, there's a couple of common frequencies. So a lot of the US guys use 14.236. In Australia, we tend to concentrate around on 40 metres, 7.177. There's a web application, this QSO finder, where you can just try to coordinate with other people about what's going on. There's a new net being started by the VK5 Amateur Radio Experimenters Group, of which I'm a member, on Monday nights. VK2 ham, Alan, who may be here. You here, Alan? Not sure. I saw some of his work at the Homebrew project, but he's got a parrot repeater running, so you can talk into that. It'll then play back what you've just talked to it. Useful for tuning. And there's some regular daily nets in various countries around the world who people use it on a daily basis to talk to each other. The main website for FreeDV is freedv.org. That's got a list of nets and frequencies. Okay, so one of the new modes is called FreeDV 700D. That's been released since I last spoke at Wyong. So the last year that was released around April, May last year. That uses the codec 2 voice codec. It's just 700 bits per second. It's got a very powerful forward error correction code developed by another ham in South Australia, a Bill, VK5 DSP, and that helps correct the errors in the signal as it goes through the HF channel. It's got a much better modem than we had before, and we put several thousand hours of engineering into this to get it to work. It takes a lot of effort to get these things to work. It's not easy to get to the sort of performance that analog SSB gets us with digital voice. But the good news is we can get error-free digital voice down to minus 2 dB SNR, and that's a very low SNR for speech. Speech quality is not great, it's not hi-fi, but you can get a message through when you can't in other modes. And I'm very happy, personally, a goal for me to outperform SSB using a digital mode was reached last year, so it was a pretty big year for me. And that's available in FreeDV GUI 1.3.1. You can download that and play around with it. Okay, I'll try a demo of FreeDV 700D. So we're all hooked up to the speaker, Mr. Music. Okay, we'll give it a whirl. So this is a colleague of ours, Mark, VK5QI, making a call between Adelaide and a receiver at the Bay of Islands, New Zealand. And there's a link to the sample if you ever want to have a listen to it outside of this. So it's a mixture of SSB and then the digital voice mode.
And this is Victor Kilo 5, Quebec, India, Victor Kilo 5, Quebec, India, running approximately 100 watts PDP. Getting a fading on the signal at the moment. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. This is FreeDV 700D, approximately 100 watts through a very, very poor signal path. Victor Kilo 5, Quebec, India, testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. And now switching back to analog. And this is Victor Kilo 5, Quebec, India, Victor Kilo 5, Quebec.
So that's the difference between the digital and analog over that particular path. Okay, there's been some work done getting FreeDV 700D to run on the SM1000. Another retired engineer, Don Reed, has been working very hard over the last year or so to get that running on the SM1000. Need to modify the code a little bit. So yes, Don's been working very hard on getting the FreeDV 700D working. There's a bunch of fairly complex code in there, but he's managed to come to grips with it and make some of it more efficient, or just use less memory and squeeze it into this little embedded processor. He's also developed some really nice comprehensive tests and done some very fine software engineering. I'm really enjoying working with him. And we hope to release some new SM1000 firmware in the middle of this year to run 700D on the little blue box there. Okay, the other thing that I'm pretty excited with and working hard on is LPCnet. This is neural net-based speech synthesis and speech coding. You may have heard of deep learning and machine learning, a bit of a buzzword, self-driving cars, that sort of thing. That's all based on this neural net, recent developments in neural net and in particular deep learning. So there's been a bit of a breakthrough over the last few years, pioneered by Google, in very natural sounding speech synthesis for systems that, you know, computers speaking. It's got to the point where it's really hard to tell that they're not real humans. That's been applied to speech coding in the academic world. In 2018, a paper was released where they used, it's a bit noisy, where they released the speech codec using deep learning-based synthesis techniques. However, the problem was that was released by a team of Google and some academics from Auckland University, and it worked great. They used my codec as part of the system that they tested. And however, because it was by Google, it was kind of a closed source system, and it was difficult to, meant we didn't have access to it. We couldn't play with it. We couldn't develop on it. However, a friend of mine, John Mark Berlin, he's a Canadian open source developer who works for Mozilla, the people who do Firefox. He developed an open source variety as part of his research, and he's been kind enough to help me understand it. It's a very new area for me. So I've been working hard on this, and I've been applying it to low-rate speech coding, in particular FreeDV. One of the other problems with the original speech coding work released into the academic world last year was that it required a GPU card to run. To synthesise speech, you needed one of those graphics cards the computer gamers used. Very high computational complexity. John Mark's managed to get it running on regular, you know, sort of computer you've got on your laptop now or your phone. So it's an open source version. It's efficient, can run on regular CPUs. So I'm working on getting it running with FreeDV so we can all use it over the air. Which brings me to the FreeDV 2020 mode. That's what I'm working on developing at the moment and hoping to release in the next few months. That consists of an LPCnet codec that's quantized to around 1700 bits per second. On top of that, we'll put some forward error correction codes, once again developed by Bill. Yes. So this uses the same modem that's working so well on FreeDV 700D over the HF channels. And I've had a friend from, I'd like to acknowledge the help of Steve Sampson, a US ham who's done a lot of work on that modem, making it run well. Now the difference with this is it's 8 kilohertz high quality bandwidth. So that's like Skype or AM radio, that sort of bandwidth. We're used to, 300 to 2600. This is 0 to 8000 hertz of audio bandwidth. But through the magic of modems and speech compression, it sits in 1600 hertz of RF bandwidth, so less than SSB. There'll be an experimental release of this in a few months, and I think, as far as I know, it's the first time a neural net vocoder has been on air anywhere in the world. Closed source, anywhere, so ham radio leading the pack. So I'll demonstrate this. Probably similar to FreeDV 1600. FreeDV 700D is around 1100 hertz. So I'll just play a few seconds from a WIA broadcast. I'll play the original speech, what it sounds like under SSB with a 10 dB signal to noise ratio, and then I'll play the FreeDV 2020.
From Australia, this is VK1WIA.
From Australia, this is VK1WIA.
From Australia, this is VK1WIA.
I'll do that. I'll play the SSB and the FreeDV 2020 again.
From Australia, this is VK1WIA.
From Australia, this is VK1WIA.
So that's what we'll be getting out of our SSB radios soon with FreeDV 2020. I'll play a longer sample, just of the FreeDV 2020.
From Australia, this is VK1WIA and the weekly WIA amateur radio news service on RF, internet streaming and text at wia.org.au.
Hi there, I'm Graham, VK4BB, the national news for week commencing January 2019 in our 24th year of non-stop news and a pretty eventful and violent week at the WIA news desk this week.
So there you go. Now that's at 1700 bits per second, the speech. That's less than what you use for DRM or any of those UHF modes. But we're getting 8 kilohertz bandwidth speech. So you're getting all that speech beneath 300 hertz and speech up to 8 kilohertz of analog bandwidth. And that will run in a HF channel at moderate SNRs. Not as low as FreeDV 700D, but if you have an armchair copy in SSB, that's the quality of audio you'll be able to get. Okay, so coming up is the FreeDV QSO party. That's been developed, been released, or being run, I guess, by the Adelaide Radio Experimenters Group, AREG. Any AREG members here today? Oh, there we have 2 in the corner there. How about that? Made the trip. Thank you, guys. And me, that's 3. That's a worldwide QSO party. As I said, there's groups all around the world, so we're going to coordinate, and there'll be a lot of FreeDV activity on air at the end of April on all HF bands. They're going to be points awarded, so it's like a competition, and there's many international records to be set. I don't know of many QSOs that have happened trans-Pacific between Australia and Europe using FreeDV mode, so it's a chance to get on air and set a few records. Now's a good time to start setting up and tuning your station. It does take a bit of fiddling to get it going, and you want to have a little bit of on-air experience before the end of April. So this is a bit of a roadmap of where we've been going. It's been going about 10 years now. I was approached by HAMS in 2009 with this problem of closed source codecs and ham radio, sort of going to areas where you've got software and algorithms that you're not allowed to play with, that are locked down. So we came up with an open source codec. A few years later, we combined that with a modem and the GUI application I showed you and released FreeDV 1600. In 2015, we put that on an embedded system, the SM1000, to have a little standalone box, and that can hook up to any existing legacy SSB radio. All these modes, people have run it on 1960 zero valve radios and digital voice over old military radios and things. You don't need a new radio. 2018, last year, we finally got competitive with SSB, with FreeDV 700D. Not great speech quality, but can get through in very low SNRs. And we've used that in some pretty poor band conditions to make contacts. And this year is going to be pretty exciting too. We'll have the FreeDV 2020 with the audio quality I just demonstrated, and also 700D running on the SM1000. So that pretty much concludes the talk, and happy to open it up to any questions. Yes? Yes. Yeah, just a push button to move between them. Yes. Yes. Plenty of room for both modes in terms of the firmware. Yeah.
Is the ultimate goal reduced bandwidth or superior speech quality or weak signal?
Oh, it's what I feel like doing in one particular year and have fun. Yeah. For a while it was didn't care about the quality, wanted to make it beat SSB or become competitive. Now I've got the opportunity to also greatly improve on the speech quality of what we had before.
What I'm wondering is the motivation to make it a weak signal mode so that it performs very well with low SNR, or is it to make it a higher quality speech mode or reduce the bandwidth?
I think there's a bit of both. This year the focus is on the latter, and last year it was on the low signal mode. So I don't think we definitely need one mode that's it for FreeDV. It's possible to have more than one mode for different situations. Yeah. You had a question?
What's under the hood of the SM1000 CPU?
It's an STM32F4, so with a floating point CPU at about 168 megahertz. That tooth's starting to get a little. That chip's getting a little long in the tooth now, but still plenty of CPU. You can get same form factor. We can get chips that are twice as powerful if we want to. Yes, yes, yeah. There's a lot of that sort of ARM stuff going on.
Have you had any conversations with Jonathan about integration of FreeDV?
No, I'm aware of his work and it's great stuff, but haven't had any direct conversations.
One final question. On the 2020 what sort of CPU power are you actually, what is it requiring? Is there any chance that it will be low enough in the future to have an embedded device?
There's a chance, but you've got to bear in mind over the last year it's gone from a GPU card down to a regular CPU, so it's pretty heavy. Currently, the slowest thing we're running on is iPhones, ARM CPUs, but ARM 9s with Neon instruction set. But if it was, say, ported to fixed point, things like that, you might be able to get it down to an STM. Yeah, that's right. Yeah, it'll run on regular PC, no problem, with a modern SIMD CPU.
When you say modern,
2010 plus. Not XP from 98. Yeah. But something with it needs the SIMD instruction set, so we're running on things with AVX instruction set under the hood, which is one of those vector processing instruction sets. It's been around for nearly a decade. But yeah, the other FreeDV modes, we've got people running on ancient PCs just fine. Yeah. Any other questions?
That there aren't. I'd say that compared very favourably with the commercial one earlier today. So basically all we need is was the DV 1000 microphone to get on air.
Or you just need the free software.
And the software, yeah.
Yeah.
Well, thank you very much for excellent presentation. And, I'm happy to give
Thank you
you
very
a
much.
certificate in appreciation of your efforts.
Thank you. Thank you very much.
Cheers.